Geometry, Semester 1, 5.51, Study on Circles, Angles, and Proofs. Here we go. An inscribed angle is an angle formed by two chords that share an endpoint. So on my lines here, I'm going to put chords. Boom. That share an endpoint. End point. Boom. Put that over there. All right, so now we're going to make our Venn diagram. We're going to fill it out. Let's keep it moving. An inscribed angle, just like I said, is formed by two chords. That's what goes on this line here. Boom. We put that there. It's good. And the vertex is shared endpoint on a circle. Don't worry about it if this seems abstract. We're going to look at some practice ones in just a second. So right there should be endpoint. Now, the central angle, that's the one we studied last lesson, is just part of a circle. Well, it's part of a circle. And it's formed by two radii. Remember, radii is just the plural form of the word radius. And the vertex is the center of the circle. Boom, boom. And a thing that they have in common that the inscribed angles and central angles are angles inside a circle. So on this line here, you will put circle. All right, let's move on. Now, for each, we're going to use notation to name the inscribed angle and its intercepted arc. So our inscribed angle here on our first example would be angle, you can write it as either angle ABC or angle CBA. And the intercepted arc created by those angles, or the arc here, which is just arc AC, which happens to be minor, or arc CA with a little curve above it. The next example to the right, our inscribed angle here. The inscribed angle here is going to be angle EFG, or we can call it angle GFE. Works the same forward or backward. And the intercepted arc, it's a major arc, so it's going to be either EXG with an arc above it, or, whoops, that looks bad, GXE. So the inscribed angle rule. The measure of an inscribed angle is going to be always half the measure of the intercepted arc. Every single time that's going to work out. So in theory, the inscribed angle rule, the measure of the inscribed angle is always half the measure of the intercepted arc. The measure of the intercepted arc is going to be 2 times the measure of the inscribed angle. So the rule, and any inscribed angle that intercepts a semicircle will be a right angle. Why is it true? The reason why is because a right angle, a semicircle, is 180 degrees. A right angle, right angle is going to be 90 degrees. As long as we remember, and I'm going to write it over here, that an inscribed angle is half of the arc, then my inscribed angle, which we don't know, is going to be half of my arc, and my arc is 180. So when I simplify that, my angle is going to be 90 degrees. So So in practice, we're going to use the inscribed angle rule to find the value of x in each circle, and we're going to show our work. So as long as you know that the angle is half of the arc, then we can work backwards. So our angle is given right here. It's 28 degrees. So here goes. The angle is 28, and that's half of our arc, which we don't know. So 1/2 x. The only way to get x by itself is to multiply both sides by 2. When you multiply by 2, you get rid of that one. But what you do to one side, you got to do to the other. So I'm going to multiply this side by 2 also. And so x, which is my arc, is going to be equal to 56 degrees. And that works by the rule because half of 56 is 28. So this is my arc, and it's 56 degrees. Okay, and once again, we know that our angle is half of the arc. So my angle, I don't know what it is. I'm going to call it x because we don't know. It was not given. That's right there. So my angle, I don't know. I call it x, is equal to half of 117 degrees. Whoop. Don't put that degree symbol. It might confuse you. So then x is going to be what I get when I divide 117 by 2, which is 58.5 degrees. So that's my answer. 58.5 degrees. That's the measure for that angle there that I didn't know. Okay, on the next page, what you're going to see is that we're going to fill in the blanks to complete the rule. We're going to write angle or arc in each blank. When two chords intersect, they form a pair of congruent vertical angles. So on this line, you would put angles. Whoops, it's writing in red. Okay, the measure of each angle is half the sum of the measure of the intercepted arc. So let's go ahead and get those in there. The measure of each angle is half the sum of the measure of their intercepted arc. And there we go. Let's practice one. So we're going to use the diagram to identify each part and measure. The intercepted chords are going to be the lines, segments AE and DC. So that's what we put on this line. Our intersecting chords are AE and CD. And our congruent vertical angles that's made by those chords are going to be ABC and DBE. Angle ABC and angle DBE. All right, the intercepted arcs, which are here and here, created by those angles, are going to be the arc AC or CA and DE or ED, doesn't matter. The sum of the measures of the intercepted arcs, if we add those two together, 110 plus 20 is going to be 130. And the measure of each vertical angle is actually going to be the 130 divided by 2, so that's going to be 65 degrees. So the angle that's 65 degrees is right in here, so that one's 65. And if they're vertical, then this one must also be 65 degrees.